So in our last video, remember we were looking at this example for each n in the natural numbers. We defined an to be the interval -1/n to 1/n. And I want us now to prove that the union from I equals 1 to infinity, ai equals -1 to 1. So here, remember what you're doing. You're proving that the set on the left equals the set on the right. So if you're proving this, remember there are two things you need to prove. We need to prove the following two things. That the union of AI, it's a subset of -1 to 1, and then the intersection, or sorry, the interval, the reverse, the interval is a subset of the union. So we're going to start with this first proof. And here we're just going to write outlines of these proofs. I won't go back and write them formally for you. So for number 1, we want to prove that the union of AI is a subset of -1 to 1. So what would for the outline of this proof, what would the start be? How should I start it? I would let X be an element of the union. And then what should I end with? What's the end going to be? X needs to be in that interval. So the end, give myself some space down here. The end will be that X is in the interval -1 to 1. What does it mean to be in that interval? It means X needs to be greater than or equal to -1, and X needs to be less than or equal to 1. So we're going to go back to our start now. To be in the union of these sets, X just needs to be in one of them. So X is in AN for some n in the natural numbers. But that means X is in the interval -1/n to 1/n. That means X is greater than or equal to -1/n, and X is less than or equal to 1/n. But remember, what do we know about n? N is in the natural numbers, so n is at least 1, which means if I divide by n, I get 1 is greater than or equal to 1/n, which means, so put this together with what you have over here, X is less than or equal to 1/n, and 1/n is less than or equal to 1. So this tells us X is less than or equal to 1. We're going to carry down this and from up here. I need a negative, though, in this inequality. So if I multiply by a -1, the inequality is going to flip. So kind of running out of room here, but I have X is less than or equal to -1/n, and I have -1 is less than or equal to -1/n. So if we put these things together now, I now can say, with these two here, smush them together, this tells me -1 is less than or equal to X. So I have what I need here, and I have what I needed there. And then you could write up the formal proof of this now using your outline. So let's look at the second part that we need to prove here. The second part of our proof, right? What was the second part we needed to show? -1 to 1 was a subset of our union. So again, we're just going to write the outline here. Once you have the outline, you can write the formal proof. So you're going to start with an element in the interval, -1 to 1. And what does so again, this is my start. What's my end going to be? The end is that x is in the union. One to infinity AI. Well, to be in the union, it just means you need to be in one of those sets. So x is in AN for some n. But remember what we did earlier. Remember, our sets are shrinking. So our largest set came from when our subscript was 1. So remember that A1 was the interval -1 to 1. So if x is in my interval, x is in A1. So then I can let n be 1, and that statement would be true. X is in A1, so x is in AN for some n. So again, this is the outline of the proof. You should go back and write the formal part of the proof. I do want to also mention we didn't use this for our specific problem, but you should review the Archimedean principle and the corollary that we discussed back in the videos that we had for this material. So you should revisit those videos and relook at those topics because you might need them in your proofs.